Assalamualaikum warahmatullahi wabarakatuh. So me and my group member from section 1 BEJ 30303 will do the presentation for our study which is catching memory analysis using Paracache simulator. So my name is AINNATUL JOHARI. So I will start the presentation first. So the objective for this study, first we need to learn to work as a team to carry out a complex design task requiring effective communication and cooperation. Second objective is to explore how the Paracache simulator work for catchy mapping, which is we have three technique for mapping, which is direct mapping, associative mapping, and set associative mapping. Third is to understand and apply the theory had been learned into an application, theory that we learn from the lecture and the class. And the last one is to have a clear understanding of the principle of the direct mapping, associative mapping, and set associative mapping. So I will start the presentation with the introduction about the processor, cache and paracache. So we know the processor is also known as the central processing unit that serves as a main computer integrated circuit IC, which is responsible to for interpreting and respond to the majority of the order that compute at the computer. It also can usually perform operation that quick operation on operand quicker than a bit capacity. Main memory can access them. However, it is not cost effective if we need to replace all the primary memory with the very high speed semiconductor memory. Hence, we use the cache. Cache is basically the system that also known as a chip memory that had been placed between the processing unit and the actual memory. So the data or instruction that had been used before and needed to be used or needed to be called again. So that data will be stored in the cache. So to do the analysis of cache memory in this study and research, we use the Paracache simulator. So basically, Paracache simulator is a collection of a workbench for cache memory, for cache mapping, and a virtual memory that are fast, simple, and initiative to use. So which is very helpful for user to explore the workbench and observe different features through the cycle of a workbench, and we able to understand the whole process of cache mapping by using this simulator. So basically, in this study, we focus on three techniques of mapping, which is direct mapping, associative mapping, and set associative mapping.
Hello and Assalamualaikum. My name is NASUHA NURHANAANI BACHO and my mentor number is AE18014. And today I'll be presenting about the methodology used in our project. So, in total, there are three types of cache mapping method, which is direct mapping, fully associative cache, and n-way set associative cache. For the n-way, in total there will be two types, which is two-way and four-way set associative mapping. Okay, so in order to make our project easier, we will predetermine our memory, cache, and tag bits, which will be memory size is 128 bytes, cache size is 32 bytes, and block size is 8 bytes. After we have determined those three values, we will then be able to obtain these values, which is the number of blocks, 16 blocks, number of lines, 4 lines, block index is 4, cache index is 2, and tag size is 2. Okay, then cache mapping workflow. In general, for those three mapping methods earlier that I have told you, their workflow is generally the same. So, how they work is, first, the requested address is put into the CPU, and then the cache index in the PA, which is the physical address, is compared to those that is stored in cache. After that, then the tag bits in the PA is compared with the tag bits that is already in the system. After that, we will compare whether the tag bits and the cache are the same. If it's not the same, then we will say is cache miss. After that, the CPU will search in the memory for the requested address. How it search? It will use the block index value in PA to find the address. After it have find the address, it will then change the value that the cache is holding, and then the tag bits will change. After that, it will go back to the start of the operation. But however, if both the tag bits and cache are the same, it will say it is a cache hit, and then it will go back to the system. Okay, so the difference between method, it lies between the instruction breakdown and replacement method. Okay, so for instruction breakdown, there are 4 things that we have to keep in mind, which is tag bits, cache index, block offset, and set. Tag bits is used to distinguish between one cache line with another, while cache index is a place where each memory is placed. And block offset is to point to the desired data in cache block, while set is used to differentiate between the type of sets for the n-way set assertive method. So, instruction breakdown. Here, as you can see, there are this instruction breakdown for the 4 types of cache mapping, which is, as you can see here. So, for example, we can see that for direct mapping, there are in total of 2 tag bits, 2 cache index, and 3 blocks for block offset. While for fully assisted mapping, we can see that there are 4 blocks for tag bits and 3 for block offset. So, from that example, we can see that instruction breakdowns for these 4 methods are not the same. Okay, now we'll be talking about the cache replacement method for each method, which is first for direct mapping. For direct mapping, for each cache line, they will be responsible for one type of least significant bit. So, for example, for line 0, it will be responsible for least significant bit 00. Meanwhile, for line 2, it will be responsible for LSB 10. And okay, so for fully associative mapping, instead, for each cache line, they will not be responsible for any type of LSB, meaning from the memory, they are free to go to whichever cache line that they want to. Okay, so for two-way set associative mapping, we can see that N here stands for the number of lines in one set. So we can see here for set 0, there is 2 lines, and for set 1 is 2 lines. So in total there are 2 sets. Okay, and then we can also see that for set 0, it will hold those with least significant bit 0, while set 1 will hold those with LSB 1, as we can see from here. Okay, next, for 4-way set associative mapping, since there are 4 lines in one set, in total there will be only 1 set for these types of data. So that is it for our methodology. Thank you.
Assalamualaikum. My name is Syakila binti Mazmin. My metric number is CE180047. So today I'm going to explain about Paracache simulator. So in this simulator, we are using cache type analysis since our project is to analyze cache memory for every type of cache. So we just click the cache type analysis. Here is the Paracache simulator for cache type analysis. So here is the part where we need to setting before we put the input. So we set into the FIFO, write back, and write on allocate. For the memory size, we put 128 bytes, and then for the offset bits, we put 3 bits since our block size is 8 bytes. And then for the cache, we are going to set 4 different type of cache. So we are going to set into the direct mapped cache, fully associative cache, 2-way set associative cache, and 4-way set associative cache with the same cache size, which is 32 bytes. And then we just need to submit. After that, we are going to put the input, the instruction that we want to use. And then just put the CPU request here. And then we just click. So here is the input part for the simulator. So we just need to submit this instruction. So here we'll display the current instruction that we have sent. And then here we can see the list of previous instruction that already submit in this cache. So as we can see at the load 20, which is from the CPU request 20, for the direct mapped cache are missed. The cache are missed, and then for the fully associative cache, the cache also missed, and then for the two-way set associative cache also missed, and then for the four-way set associative cache, the cache also missed. And then we can see the percentage of the hit and the miss after we submit the instruction. So we can see the hit and miss percentage here. And then to get the result for part one by one, we just click the next instruction. So the next instruction will go inside this current instruction. And we can see here the list of previous instruction is 6 because we already submit the instruction in this cache. And then to make it fast, we just fast forward. And then all the instruction will be transferred in this cache. So we can see here the list of previous instruction. All instruction will be have in this cache. So we can see the percentage for the hit and miss. So for the hit, so the direct mapped cache, we got 8% for the hit cache, and then the miss cache is 92%. And for the fully associative cache, the hit cache is 17%, and the miss cache is 83%. And then for two-way set associative, the hit cache is 25%, and then the miss is 75%. And for the four-way set associative cache, we got 17% for hit cache and 83% for miss cache. So for every type of cache, we will get a different percentage for the hit and miss, since the hit that happen in every type of cache are different. And then, I forgot to show you, this is the part where is the output part of this simulator. So that's all from me. Thank you.
Now I'll present about the discussion. Paracache purpose is to provide a complete tool for memory management simulation as well as details on the hardware component that makes it possible. Based on the simulator features we use, there are some features that are the same as in the previous study. The following features are incorporated into the tools. First, store instruction. Another characteristic that distinguishes Paracache from another available simulator is the store simulation by using write-back and write-through instruction methods. Only when write-back is enabled will the main memory will be updated. As a result of the block being replaced in the cache, there will be a brief lapse in the communication between cache and memory. Write-back is more efficient since it does not require access to main memory every time data is modified. In the meantime, writer on allocation will bring the data into cache and update the content. Only the main would be written to if you write around memory. Next is virtual memory and paging. Virtual memory and paging are important concepts in computer structure and architecture. Yet there are few tools that to demonstrate them in depth simulator diagram. Memory is important in large system. The procedure will be broken into page frames and will have access the virtual pages that provide memory space. Depending on the offset gives in the settings, the virtual address will be broken down to page and offset. As a result, TLB will be used to search the page. TLB hit the executed if the page has the same data as the TLB frame. Otherwise, page will be searched indefinitely in the table and of contents. Page table works on the table as ideas as page time with cache that is directly mapped. The page you requested will be shown at the page table, then a specified index was searched. Patch data hit that patch data hit is done if the patch in the table is valid. If the patch is failure occurs, the data will be retrieved from the secondary memory. If a hit detected, patch data will be retrieved from the physical server memory with the required offset. Paracache is a virtual memory and cache simulator with a comprehensive overview. It assists users in seeing and comprehending and fundamentals memory management ideas. The users acknowledge that the Paracache simulator aids in the understanding of cache and virtual memory concepts and has illustrated these ideas in a clear and concise manner, also have enough features to allow people progress with the look of the memory management ideas. The performance of the Paracache was performed in being a system's usefulness. That's all from me. Thank you.
For the Q&A section, I will answer the question number 1, which is what are the unique features of your child project. So basically, in my opinion, I will think the Paracache simulator itself is a very unique features in our project, because Paracache simulator is very helpful and easy to use even for the beginners, because it's a provide is describe each step with the visual and the textual acts, and provide a clear understanding to understand all the principle about the mapping, which is a direct mapping, fully associative mapping, set associative mapping, virtual mapping, and badging. But we just only use 3 technique of mapping, and it also has the feature that very help to improve the learning experience of memory management, which is we have a camera, ECS simulator, and Cashier sim. So basically, I think the Paracache simulator is a very unique features in our project.
Okay, so my question is question 2 for the Q&A session, which is what does current trend of computer architecture is related with our project? So our project is definitely related to the cache memory and cache size aspect of CAO. This is because in our project we delve into what type of cache mapping method there is and how they work, both manually and by using Paracache. We also try to determine which of those methods are the best by trying to obtain the cache hit and cache rate, and also the non-gate use from our predetermined setup of the cache memory. By doing our project based on this, we are able to understand how cache memory works. And this in turn will also help us to better understand our computer architecture, since cache and virtual memory is such an integral part in the computer. Thank you.
Question number 3. Explain on how your project can support the sustainable development. So our project analyzing memory cache can support the sustainable development SDG 9, which is in industry, innovation and infrastructure. As we can see, nowadays the technology become more advanced. The system performance for the laptop, computer, smartphone and the other gadget become more faster and more easier to use. And people keep demand to have the system performance for the gadget like smartphone, laptop and computer become more fast and fast. Example like we go to the store to buy a laptop, we must look in the laptop that have the fastest and good system performance. So that's why we need to analyzing cache memory for every type of cache to find which cache have the good performance. Since we know cache is faster access memory than RAM, since it is on the same chip as the processor. So that's all from me. Thank you.
Okay, so for question and answer part, I got a question that asked me to explain the current trend of computer architecture for sustainable development. So what I got for the answer is, in the coming years, there is a scope of a lot of research work that needs to be done in the field of green computing. So research could be concentrated around making data center and cloud computing more energy efficient. The corporate organization must take more green initiatives, and all the stakeholders must work jointly for a renewal. Otherwise, the human race will face several problems in the coming years. So that's all for my answer. Thank you.